to my YouTube channel. Thanks for coming back again if you have subscribed. And if you are yet to subscribe, just click on the subscribe button and also on the bell beside it to notify you when we drop a new video. And I appreciate you guys for a job well done. Thank you for 4,000 subscribers and above, and you can do more than that. I really appreciate. So let's look at the salt analysis for the WAEC 2023 chemistry practical. So we have two salt given to us. Anyway, let's call this salt at the beginning. So but at the end of the experiment, what we deduce from the experiment will tell us what exactly the samples are. Okay, let's look at the question that has been formulated as a result of the available specimens or sample. So we are given two salts, okay, two samples. One is labeled D and the other C. Okay, C first before D alphabetically. So one is labeled C and the other is D. So we are told to carry out the following test on the samples. So you are provided with salt C and D. Carry out the following test on C and D. Okay. The first we have to take it one after the other. So let's take sample C first, then we take sample D as we proceed. We are going to show you the practical view of everything, but let us go through the question and see what we are meant to do. And I've written out the text out there in this table. So whatever the observation and inference we get from this practical, we're going to fill in the gaps here. So now let's look at the first one. To little portion of C, add about 10 centimeter cube of water. You don't necessarily need to measure 10 centimeter cube of water. Just add enough water that is going to be enough to dissolve the sample you put in the test tube. So that is the first thing we are going to observe and give our input on that. Now test the resulting solution with litmus paper to check if the solution is going to be acidic or basic. So we have to test with both red and blue litmus paper to see if there is any response to any of those papers. So then the next is to solution C. To solution of C, that is the solution that has been prepared earlier by adding water. Then you are going to add acidified K2CR2O7, that is potassium heptaoxodichromate 6. So we are adding that to give our observation and inference. Then to solution of C, that same solution, we are meant to add Fehlin's reagent. So the Fehlin reagent is Fehlin A and B. We are actually adding the both reagents. We have to add Fehlin A first, then we add Fehlin B, and what else? We are told to eat that strongly. Then we give our observation and inference in that situation as well. So now let's go for the second salt. We are actually done with first salt C like that. So let's look at the second salt. Take little portion of D and eat strongly. So we are going to eat the little portion of D we are taking. Then thereafter, take to another portion of D. We are going to take another portion of D. Add dilute HCl in the test tube. So hydrochloric acid. Anyway, if hydrochloric acid is not available, you can actually add tetraoxosulfate 6 acid, that is H2SO4. Now, then the next is divide the solution into two. That means after adding acid into it, we are going to get a solution, divide it into two portions. Now, after dividing that solution into two portions, then add dilute sodium hydroxide to one of those portions. And you add it in drops first and then in excess. And you give your inferences both in drop and in excess with observation. Now, to the second portion of the solution D, add NH3, which is ammonia, in drop and in excess as well. So you give your inference in both cases. So in a nutshell, we are going to look at how the experiment will be done now, and let us see all this observation and give our inferences from what we see. Okay, now let's look at the experiment. So according to the first step for the sample C, so this is sample C now. We have seen the C labeled C. So we are told to add few centimeter into, we should add it to a test tube, and then we add few centimeter of water. So let's do that now. So I've actually, in the absence of spatula, I use this to take the sample. So then add into the test tube. So actually I will need a test tube holder. Let me hold. So I have added it into the test tube. I'm holding the test tube right away. So let us add few centimeter cube of water, which is enough to dilute, to dissolve it rather. So let's do that. So let's see the response. All right. Okay. As you can see, it feels cold when touched as it dissolves, so it means the dissolution of this particular sample is endothermic in nature. It is endothermic and it dissolves completely. So no residue, no remain. So it's all dissolved completely. Okay. Okay, let me try that once again to get an output. Since this is containing, okay, I will change the test tube now. This is actually a boiling tube. So let's add sample C now in a small amount. So I've done that. So let's add few centimeter cube of water. Oh, it dissolves completely. This is it. It dissolves completely. So what is our observation? C dissolves completely to a colorless solution. The solution is colorless and it dissolves completely. And while dissolving, the test tube appear colder. So it means the dissolution of this is an endothermic process. So and then what do we say? C is a soluble substance. Then that is the inference. Then the dissolution is exothermic in nature. Then okay, that is the inference I can get from this observation. So the next step is aqueous solution of C plus litmus paper. So we have to test this solution with litmus paper. So let me hold it here and then get the litmus paper to test it. So this is red and blue litmus paper. So I'll pick, you can actually use the two at the same time, but I would advise you use one first before the other. So let me use blue first. So I'll cut my litmus paper. This is blue. Okay, endeavor that your hand does not contain any acid or base that will change the color of the litmus paper before you test it. So let's test the solution with it and see the changes that may occur. Okay, if you look at it, as I dip it in, there is no changes at all. It still remains blue. So solution is not acidic. So now let's check for red. Let's check for red to see if there will be any changes. For red litmus paper, let's check it out. So this is red litmus paper. So let's test the solution with it. Okay, as you can see, it still remains red and there is no change in litmus paper. So that is the observation. Then the inference will be C is neutral. C is a neutral sample or salt. So that is the inference on that. Then what next? Aqueous solution of C, which is this solution. We will now add potassium heptaoxodichromate 6 to it. So we'll see the difference, the changes that will take place after adding that. So this is K2Cr2O7. I will add it into it, but I can actually divide this portion into two so that I can get, or probably make another portion when it is time for me to do the other test. So okay, let me keep this, rinse this, then I make another portion. So let me make another portion of it. So just like it dissolves, you can see it now. So now let me add my K2Cr2O7. So this is it. So let's add it in a little amount first to see the changes. So what do we notice? So I didn't see a quick change in this, so let's keep it for a while to see if there is any change while we proceed with other tests. So now the next test is aqueous solution of C plus Fehling's solution. But actually, let's now test this. This is Fehling A and this is Fehling B. So Fehling's solution is we are going to add these two solutions to it. So while we do that, let's do that now. So how do we achieve that? So I will actually measure small part of Fehling A first. Okay, Fehling A first. Yeah. Fehling A first. Okay. So this is Fehling A. Let's add it a little bit into the solution. Okay. On addition of Fehling A, this is what we have. So let's go ahead to add B as well. Let us add Fehling B. So A being closed. Fehling A has a blue color and is a solution of copper sulfate. So let's add Fehling B and see the response. So when we add Fehling B, is there any changes? So no changes yet. Then the question asks us to heat the mixture of this. So let's go ahead to heat the mixture. So in the availability of Bunsen burner, I'm going to improvise in a very funny way. So let us heat the solution and see. We are already heating it now, as you can see. Anyway, with candle flame. So let's heat and see if there is any response. So we can see the solution is actually turning to a bluish color. Slightly blue or greenish or bluish green, whichever one. Let's take a closer look to that. So that is it. So let's keep eating and see if there is any response. So now from blue color, I just have to make it an open flame. From blue color is turning a kind of brick red solution or reddish. From that blue migrating gradually into red color, or let's say not completely red but brick red from that angle. So that's what we are seeing now. So these have inferences in each case. Now let's start giving our inference. Okay, like I've said, the first one, the observation is that it's soluble in water and it forms a colorless solution. Then inference is sample is soluble and is endothermic. Then the next is we have aqueous solution of C with red and blue litmus paper. It is a neutral, that is the inference. Then aqueous solution plus acidified KMNO4 K2Cr2O7. Okay, we kept that and that has actually changed to color green. Then this last test we are doing now, we discovered that the color changes to blue as we eat, but as we continue eating, we started seeing a brick red appearance on it. So in each inference, when dichromate is added, the inference in that case is that probably alkanal or hydroxyl group is present in this sample. So the sample is actually probably a reducing agent. So now the last test we did here, which is the Fehling test, we discovered that alkanal CHO group is present. Then C is then concluded to be a reducing sugar. So now let's go ahead to perform the test for D. The test, second test on D, this is salt D. So let's look at it. So and we are meant to perform the first test. We said take a portion of D and eat strongly. So I'm going to take a portion of D undiluted. So I'm not going to dilute it with anything, just eat the salt directly like that strongly. So to eat it strongly, I'm not going to use this. So I want to eat it with a direct flame. So it will be very, very strong. So now let's take sample D. Okay, now I will add it to the boiling tube and then I will heat. So let's see the response. I observe a yellow change in the color of D. There is a yellow change in the color, but very, very slightly. I don't think you can see that over there, but I can see it. So in order not to waste time, I have observed a slight change in color, which is yellow, due to the fact probably because the heat here is not too strong, so you might not be able to see that clearly over there. So but I can see it here. It has turned a bit yellow. So just because the flame I'm using is so luminous and contains, so it makes this dark. So but let's put it somewhere to see what happens. Okay, it appears kind of yellowish but still looking white in the camera. Okay, let's leave that aside. So now let's move on to the next step. We're told that we should add HCl to sample D. So now let's take sample D and add few centimeter cube of HCl. So this is the next. So for sample D, let's add few centimeter cube of HCl. Fill this with water. So this is sample D. I have not put the sample there. So adding it to the test tube, and then let's add few centimeter cube of HCl. Okay. So let's add few centimeter cube of HCl. Maybe just enough to dissolve it. All right. So we have a white solution. A white solution here. So let's see if it might actually turn or changes. Okay, we have a white solution produced. So now let's divide this solution into two portions. So we have a white solution, so but there is no precipitate, no part of it that is not dissolved, so everything dissolves into a white solution. So and okay, does it feel warm? Okay, it doesn't really, it feels a little bit warm, yes. So it shows it's an exothermic process and the salt dissolves in the acid. So let us separate the solution into two. So I have two distinct solutions here. Let's keep one and perform test on one. So now to the first part of it, let us add sodium hydroxide. Let's add sodium hydroxide to the first part. Okay, I'll get that now. So this is sodium hydroxide. So let's add it to the first part and see the changes that must have occurred. So in drop first, So in drops, what do we notice? So there is a white precipitate, white gelatinous precipitate. It looks like gel-like on the surface. So let's add it in the excess. Okay, the precipitate becomes soluble in excess. There is a white gelatinous precipitate in drops, and then in excess it becomes soluble. Okay, which means in the observation, then the inference rather is probably zinc is present or aluminium is present. Zinc ion or aluminium ion is present. So for the first one, sample D plus strong heat, it turns yellow. Now it has turned back to white as it cools. Wow. So this shows that, okay, probably zinc might be present. So the substance might be thermochromic. So now the next is we added HCl and it forms a solution, and which we divided into two. The HCl solution is kind of exothermic because it feels warm. Then when we added NaOH, there is a white precipitate, then which later dissolves in excess. So that is the inference gives is either aluminium or zinc is present. So let's take the second part of the solution. Okay, taking the second part of the solution, we are going to add ammonia to it. On addition of ammonia to the second part of the solution, what do we have? Let's move on to that. So let us add ammonia to it in drop and then in excess. Okay, there is also precipitate form in drop. So let's check in excess. Precipitate also becomes soluble in excess. Okay, precipitate becomes soluble in excess. Okay, now this has proved the presence of zinc because the solution has a precipitate form in drop as sodium hydroxide is added and also dissolved in excess. So the same thing happens when ammonia is added. So this has proven that the compound is a zinc salt. So zinc is actually present. So now we have done that. So let's check our results from the table. We should check our observations and inferences from the table. So for the first test on C dissolved completely into colorless solution and test tube feels warm. So it indicates that sample C is soluble and the solution is exothermic. Then later on, C plus litmus paper shows that it's neutral because it doesn't respond to the blue and red litmus paper. Then C plus acidified potassium dichromate, we discover that the solution turns green after a while. So which means the alkyl group or hydroxyl group is likely to be present. So then the failing test performed for C discovered that the solution turns a little bit blue and then brick red later, so which has confirmed alkyl group present. Then we can say C is a reducing sugar. Then let's go for D. D plus strong heat, it turns yellow. Then when we leave it to cool, it turns back to white. So we can say zinc is likely to be present. Then on addition of HCl to D, it dissolves and the test tube feels warm. So it is soluble in acid according to the inference, and the solution is exothermic. Then after that we have D plus HCl plus NaOH. So the solution D, which was prepared from HCl, NaOH is added to it, and there is white precipitate which is gelatinous in nature. So and this gelatinous precipitate now, when we add it in drop actually, then in excess becomes soluble. So we suspect aluminium ion and zinc ion. But at the addition of ammonia to another portion of D and HCl, we discover that the same thing which happens in sodium also takes place in ammonia. In drop there is white gelatinous precipitate and it's soluble when we add it in excess. So that has confirmed the presence of zinc. So D is a zinc salt, while C is a reducing sugar. Thanks for watching this video. Endeavor to subscribe and share this video to people who really need it. Thanks for coming back again. If you are a subscriber, wish you all well. Good day.